Hello, everybody. Welcome back to Planet X News. This is Scott from the Nibiru channel. We are here this afternoon on May 15th, 2017 with our Planet X physicist and Mr. Chris Potter. How are both of you today?
Very well. Thank you, Scott. And how are you?
I'm doing all right. Not too bad.
Doing good. How are you doing, bud?
I'm hanging in there, man. It's been a pretty tough week. Tough weekend, but bottom line, we get through it all. Today, ladies and gentlemen, we're going to be talking about earthquakes, Planet X, and we're going to talk about the dynamics of earthquakes. I feel that this is very, very important considering what the Earth is currently going through, and we've seen a major, major uptick in magnitude 6 and above earthquakes over the course of the past 10 days. And there's been a lot of talk about this so-called stealth CME. I've done some research on this stealth CME phenomenon, and I really couldn't find anything related to this subject past this current week. And after viewing some information over the course of the last 48 hours pertaining to our magnetopause and the solar wind, it seems to be that this whole stealth CME, to me, is nothing but propaganda. Basically, a story put out there to disguise what is actually happening. Now, earlier this morning, and I mean very, very, very early this morning, I did a live stream showing everyone the magnetopause, the solar wind, and the radiation levels here on our planet. And the situation went from bad to worse in the course of 4 hours. And this stealth CME was set to impact the Earth on or about the 15th of May, meaning today. The solar winds were at about 365 kilometers per second, which is about 860,000 miles per hour, relatively low. And then within a 4-hour period, they doubled. But we were seeing these huge fluctuations, basically what looked like waves of energy impacting the Earth, turning the bow shock bright red, which means heavily ionized particles impacting our planet. This situation does cause the influx of earthquakes. And we've been seeing earthquakes in areas of the world that normally don't have earthquakes. There have been several earthquakes over on the east coast of the United States. And several hours ago, there was an earthquake right smack dab in the middle of the New Madrid Fault. The earthquakes are increasing along the Cascadia subduction zone, along the coast of British Columbia, the state of Washington, Vancouver, Oregon, and Northern California. And ladies and gentlemen, I've done a couple of videos on this. I've showed you some information on news reports that have been put out there back in 2016. Scientists and seismologists, yes, they've been talking about this overdue for Cascadia for some time. But the bottom line is now the Earth is in a prime situation where if something like this occurs, we're looking at a magnitude 9.2 and above that would rock Cascadia. If you've seen my videos that I put out over the last 48 hours pertaining to this, it's a very, very scary situation. And the situation could be, well, it will be absolutely catastrophic. And we're talking about the security of millions of people. So I've asked the professor to put together a report, and let's detail what exactly happens with the earthquakes. Let's talk about the dynamics of earthquakes. Let's talk about what is inside of the earth and how it is affected by these other magnetic forces that are literally in a tug of war with our planet. Now, I've had a lot of emails. People are asking me, hey, the moon is not in the right place. This is true. This is very true. There have been a few YouTube channels that have done some videos on this. I myself was outside last night at 10 p.m. using my star map application on my cell phone, pointed directly at the moon, and the position of the moon on the star map pertaining to where the moon was actually in the sky, it was actually further south. Seeing it with my own eyes. So, I mean, that actually had me a little startled, because you wonder how that's possible. And you really start to think, how close are we? And we know damn well that mainstream media, they're not going to give us the answers. NASA is definitely not going to give us the answers. As I have mentioned earlier today, they have already kind of blocked the professor from accessing SETI and possibly stereo and all of the tools that we use. She cannot get into these websites from her home computer. That's telling you something. Someone is most definitely listening to us. And then I come to find out earlier this morning that the video that I put out on YouTube showing the blue brown dwarf that I was able to capture on my telescope on May 10th, out of all of my videos, 637 videos I have produced pertaining to Planet X, Nibiru, the Nemesis solar system. Out of all of those videos, I have never had a video demonetized for the advertising from YouTube. But lo and behold, the one video that YouTube sends me a notification that the video was not advertiser friendly was the video showing the blue striped brown dwarf. The video is still up on my channels, but they claim it's not advertiser friendly. Well, ladies and gentlemen, yesterday I was setting up the telescope, setting everything up at 6:30 p.m. to try to capture some more photographs. I set everything up. I put a blue filter on the equipment, and my cell phone rang. I went to take the call. I was gone for 3 minutes. When I came back and set the laptop up and the camera, I noticed when I was looking through the viewfinder, there was a small, round, black ring in the middle of my viewfinder. I couldn't figure out what it was. I took the telescope apart. I took the mirror out of the telescope, repolished it, reinstalled it, looked through the viewfinder, and that little black ring was still there. Then I figured it out. In the 3 minutes that I took that phone call, the sun had burned a ring, melted a ring right in the center of that filter. So either my telescope was attacked, or we were looking at the sun simulator, and the sun was magnified, like, remember as a kid playing with a magnifying glass, and the sun, and burning little ants or whatever you can catch on fire. Well, that filter is absolutely ruined. It has a hole burned right through it. The only thing I can figure out is that the possibilities that the telescope was pointed directly at the sun simulator, the intensification was too much, concentrated, and burned a hole right through it. So we know that we are definitely onto something, and you know, the more and more information we gather, I think the better off we're all going to be. As I've mentioned time and time again, knowledge is power, and that's what we're seeking. Hey, listen, the rest of the world, all of the elite, the governments, the politicians, yeah, they all have power. Well, I think it's time that we, the people, have our own power. And the doctor, the professor, and she's here to give us that power and to give us that knowledge. And with the help of myself and Chris Potter, we're going to continue each and every day to do what we have to do. Just the bottom line. So today we're going to be talking about the dynamics of earthquakes, so everyone has a full understanding of what's happening. And we're going to go ahead and jump right into this. Chris, did you have anything to say while I have set this all up?
No, sir.
Doctor, how are you? Is it still snowing? Is it still snowing in South Africa?
No, it's still very cold. I had to put an extra blanket on my bed. It's very cold. But yeah, it's getting better. It's not. I don't think it's snowing anymore. It's just colder than usual.
Okay. Well, I'm going to go ahead and share this screen over here. And hopefully we don't have any technical difficulties.
Mm-hmm.
Okay, could everybody see that on their screen?
Yeah. I can see
what causes earthquakes? What causes earthquakes? I've always been fascinated by earthquakes and the dynamics of earthquakes. And there's still a lot of studies going on around the world. But at this particular time, I think that one of our biggest threats right now is the fact that these earthquakes are getting bigger. They're getting stronger, and they are now occurring in areas that normally don't see an earthquake. So I'm going to go ahead. I'm going to turn everything over to you, and we can rock and roll.
Thank you, Scott. Okay, so I spent some time, writing this report, and I had to think about it carefully. And there are a couple of factors that come into play when we're talking about earthquakes. And the most important is, what is the Earth and what's it made of, and things like that. So we start here in the first diagram. It shows the different layers of the Earth. It's got the crust, and then below that is the mantle, and then below that is the core, which is divided into two parts. The inner core is solid, and the outer core is liquid. And earthquakes, of course, can happen in the crust and in the upper portion of the mantle. All right, so the crust is where we live, and but the Earth's crust is fractured. That's the most important part to start off with. It's got cracks all over the place, and earthquakes happen at these cracks. Okay, so the crust is about 100 kilometers thick. And it's thinner where the oceans are, and it's thicker at the land masses. And then, okay, so let's scroll down a little bit so we can, the diagram below this shows the temperature, okay? So the temperature inside the Earth, right at the center, is 6,000 degrees. And then outside of that is 3,800, which is, I mean, yeah. It's 11,000 Fahrenheit, the inner temperature. Okay, so what actually happens is all objects start out hot. And I don't go into this in this report, but I actually think that what happens is planets and stars come out of other stars. For example, we have lots of binary systems because stars fission into two stars if they become unstable. And I think what happens is stars are also able to eject planets, and some of them will be rocky planets or will turn into rocky planets. When they eject, they're just as hot as stars are. So they're basically liquid metallic elements. And then when they cool down from the outside. So that's why the crust will solidify first and become rocky. And when that happens, it should be solid without fractures in it, just a solid block of rock. So the fact that the Earth is fractured means that something happened to it that caused it to fracture. And that may have been a huge cataclysmic event. So now the Earth is fractured, and so it's broken up into blocks of rock. And if we scroll down a little bit more, we can see how they are, some of these blocks. They call tectonic plate boundaries. These, the red lines there are the tectonic plate boundaries. These are where the major fault lines are. There are also faults inside the tectonic plates, but these are not as important because most of the earthquakes happen at these boundaries, which we see here. Okay, so large fractures in these, and this is what it looks like. And we see Africa, for example, that's the African plate right in the middle, and the North American plate to the left, and so on, yes. But each continent has a boundary all around it, where these fault lines are. And these fault lines are moving in a certain direction, or tending to move in a certain direction, which exerts a force on the fault line. So for example, the African plate is moving northeast, and below that, you see at the fault line below Africa, the African plate is moving north and the Antarctic plate is moving south. So these are diverging, and you get a certain type of earthquake at diverging fault lines, and you get other types at converging fault lines, and so on. So I explain all this in this article. So if we move down a little bit more, I've tried to use a lot of figures. Okay. Now, what puts pressure on the Earth's crust and causes it to move? Because there's a lot of friction between these blocks of rock. So they don't just move for any reason. Something puts pressure on them. And it's believed that it is to do with magma moving inside the mantle and forming what's called convection currents. My own theory about that is slightly different. It has to do with magma moving, but I actually think that the magma is moving in channels. It's just not moving exactly as it's pictured there. So, but my idea is not that far from this. So the magma moves upwards, and then as it moves up, it cools down. And when it cools down, it becomes denser, so it gets heavier, so it tends to fall down into the mantle. And the mantle is not completely solid. At least the bottom part of it is mainly molten magma, molten rock, which we call magma. So this magma tends to rise up and move around and form currents, which are called convection currents. And this kind of movement puts pressure on the crust. And when there's pressure on the crust, there's pressure mainly on the weak places, which are where these fractures are, or the fault lines. So, and what happens is then there are forces exerted on these fault lines. So if we move down, I think we can see some of the pictures I have for this. Okay, so there they are. So these are the two different blocks that we see on either side. And the fault line then is the middle of the block that splits it into two. And the top picture, we see that the two plates are tending to diverge. And when that happens, one of the plates, when there's a slip, so put onto these two plates, they first locked in position because of friction, because they have jagged edges, so they sort of locked in place. Then the forces that are acting on it, which are in the direction of the yellow arrows, okay, because they want to slide. The one closest to us will want to slide downwards, but friction keeps it in place. But eventually the forces, they build and build in strength until eventually the frictional forces are overcome when you get to a critical level. And when that happens, there's a sudden slip. And that sudden slip will cause the block closest to us to shift downwards in relation to the other block. And that type of fault line and the type of slip you get is called, we call it a normal fault. And then in the middle one, you see the two plates are tending to converge. That is, they're pushing against each other. So it's almost like they're trying to push one into the other. And when we have that kind of forces at the fault line, then the one closest to us will tend to move upwards in relation to the one behind that. And this is called the reverse fault. And then the third one, I mean, there are others, but these are the main ones. The other one is when the plates are tending to slide past each other. So you can see that's shown by the red arrows. Now there the forces are parallel to the fault line. And the frictional forces are in the opposite direction. And the frictional forces are keeping it from moving. But eventually the pressure is so great that there's a slip. And then the two plates move past each other, slip past each other. So these are the main types of movement that leads to earthquakes. Okay, so we can move down a bit more. Okay, now when the slip happens, you get what's called a vibration that then travels through the earth. And a lot of this vibration is like sound waves. So for example, if you have a drum, you know, it's got a membrane, and if you have a drumstick, you hit the membrane on the drum, and then that membrane vibrates. And when it vibrates, it causes air molecules around the drum to vibrate as well. And that kind of vibration is shown here in this diagram. So on this side, on the left-hand side, you have the vibrating diaphragm, which is like a drum. And when you allow it to vibrate, it causes the air molecules in this tube to do this. You get a portion where the molecules are less dense, and then you get another portion where they are denser, they are closer together. So where they are dense, it's called the compression, and where they are less dense, it's called rarefaction. And this alternative rarefaction and compression travels through the tube, and this is called a sound wave. Now, the eardrums in our ears are like the membrane on the drum. they actually vibrate when they feel these alternative rarefactions and compressions in the air travel right up to the ear. And then our brain interprets that vibration in our eardrum as sounds. So that's how we hear sound waves. And what happens in the earth is similar. And they're actually called seismic waves, and they travel right through rock. But some of them are very similar to sound waves. So if we scroll down a little bit more, we can start talking about these seismic waves. There are two types. There are the surface waves and the body waves. The surface waves are actually what we feel the earthquake, because they travel right through the surface and we standing on the surface. But the body waves are what travels through the body of the earth, so inside the earth. And there are two types. There's the P wave and the S wave. The P wave is just like the sound waves. You get alternative compressions and rarefactions, which you can see there in the diagram. So the little blocks represent rock, and the rock molecules are compressed in a certain region, and that compression travels through as a wave with the rarefaction, which here they call a dilation. All right, and then the S wave, it's different, where the rock moves up and down, and that movement is perpendicular to the direction of motion of the wave, which is from left to right, indicated by the blue arrow. So these are the waves that travel through the earth. Now, the P wave is the fastest of the waves, and that's the one that is just like sound waves. And animals can often pick up that as if it's a sound wave. So dogs sometimes start barking way before anybody on the surface feels the earthquake, because the P wave travels so fast and they picked it up. They heard it. That's why animals often act strangely, because they pick up these waves. The S wave travels a little slower than the P wave, but it can only travel through solid rock. If there's some liquid in the way, then it stops flowing, because it cannot travel through liquids, because liquids cannot support this type of up and down motion. They can only support this, it's called a longitudinal motion, which is along the direction of the wave, which we see in the P wave. So the P wave travels through solids and liquids, but the S wave only through solids. Okay, and then there is the actual surface waves. So if we scroll down a little bit more, we can look at what the surface waves look like. So these are actually what happens to the surface of the earth. So the top one is actually called the love wave, because the particles go through this kind of circular motion, and you get, it looks just like what we see a wave looks like on the surface of the ocean. And then the one before that is the Rayleigh. It has a slightly different pattern, and you can actually see it's got a forward kind of motion as well as the up and down motion on the surface. And these are actually what we feel. If we're on the surface of the earth and there's an earthquake, we may actually feel the earth moving up and down beneath our feet. These are the body waves traveling through the surface of the earth. And these are what damage buildings and cause all kinds of disasters on the surface of the planet. Okay, so if we move down further, I show one interesting phenomenon, which is liquefaction. And this happens due to the body waves traveling through soil, which is filled with water. And when that happens, so it's waterlogged and fine soil. And when that happens, these body waves actually cause the soil to become liquefied because there's a larger separation between the rock molecules, and water fills in those spaces so that the soil starts behaving like water. And when that happens, as the wave goes by, it's like the ground turns into a liquid, and we can then have cars flowing into the ground. And then afterwards, after the earthquake is over, we see what we see there, which is a car that is immersed into the ground, which is very interesting.
Yeah, that's very scary. I've read about this liquefaction before, and
Yes.
this is a very, very dangerous moment during an earthquake, because this happens very, very rapidly, and it's almost like quicksand, and there is just about no way to escape it. It's very, very heavy material. It's not like swimming in water. If you are stuck in a liquefaction situation, the party's over. That's all I have to say. It's over.
Yeah, and it's very damaging to buildings, because basically buildings lose their support from the bottom. So they will lean over and partially become immersed into the ground as well. So fortunately, I see the buildings here. It was only the road that was went through liquefaction here. So the cars got immersed. Hopefully there were no people in it. Okay, so we can move a little bit further down. I think then I start talking about the Cascadia subduction zone. So there are a few areas on Earth that are prone to really large earthquakes, and this is one of them. So the first thing you notice from that map is that you don't just have the Pacific plate and the North American plate next to each other. There are other plates in between, which tells us that the Earth is particularly fractured in this area. And that may be also why it's so prone to huge earthquakes. But as you can see, it runs from Vancouver Island to Northern California. It's about 1,000 kilometers long. And it was discovered that it experienced a huge earthquake in 1700, which is about 300 years ago. So the geologists have been studying what happened during that time, and they discovered that it can happen again anytime now. And that is the problem. So if we move down a little bit further, I think I explained a little bit more of what can happen in this area. As you can see in the diagram, there are two plates, okay, at the Cascadia subduction zone. And at the moment, what we have is what's shown in the upper diagram, where the two plates are locked together and they are converging. That is, the two plates are trying to move into each other. So the top plate, which is the North American plate, is trying to actually move above the plate that's in the ocean, between the Pacific plate and the North American plate. They have different names, these plates there. So you see that the point where they are locked is actually below the sea level, which is indicated by the blue dashed line. All right, so now what happens is there's a lot of pressure on this fault line. And as this pressure builds, eventually there should be a slip. And when the slip happens, we see what should occur in the diagram below. So at the fault line, the top plate, the North American plate, would slip upwards. So slide up over the plate next to it. And we see the two little arrows there showing the kind of direction it would move in. And this would happen suddenly and, of course, cause a huge vibration, which would travel outwards from that point. And that would cause the earthquake. But at the same time, the land masses would move. So the land mass that is close to the coast, at the moment it's rising slightly because of the pressure. It would suddenly be moved, forced down, and it would then be below sea level. At the same time, because this kind of fault is in the ocean, it would create a huge tsunami. So the tsunami would move towards land, and at the same time, the land right there would be moving down. So a huge area would be inundated by this wave. And the earthquake that happened in 1700 caused a tsunami that is thought people think it was 100 feet high. So that's very high. And it would cause enormous damage. And because the land on top of that would be moving downwards, the tsunami would travel even further inland. And even if people tried to move to higher ground, which would be that hill area, it wouldn't really work because they would have to move much further coast in order to reach an area that was way above sea level. And then further out, that bowl-shaped area would be forced upwards at this time when the slip happens. So this is what would happen at the time of this earthquake. And the earthquake that happened in 1700, I think, was a 9 magnitude earthquake. So it's very strong. It would cause enormous damage and probably loss of life, extensive loss of lives. All right, so we can scroll down a bit more, Scott. Okay, there I just explain about the 100-foot tsunami and so on. And then this is the evidence that the geologists have found. First of all, there's Native American oral history. And they looked at the geology and they found lots of evidence. And then they found what are called ghost forests. And these are forests that were above sea level, but when the earthquake happened, was suddenly immersed because the land where they were suddenly moved downwards below sea level. And the remains of these forests are still down there in the ocean. And then there were reports, of a tsunami arriving at the same time in Japan, which they called an orphan tsunami, because they didn't feel the earthquake that caused that tsunami, but it was caused by such a huge earthquake that the tsunami that hit Japan was still 16 feet high. And they knew about tsunamis then, but they didn't feel any earthquake because they were too far away from it. So they called it an orphan tsunami. And then the other piece of evidence is the seafloor turbidites. And turbidity is the movement of sediment that can sometimes occur suddenly when there's this jolt from the earthquake. So a whole lot of sediment comes down the hill into the ocean because of the sudden movement. And they found evidence of this happening on average every 250 years in this area for about the last 5,000 years. So the fact that they think that because we haven't had an earthquake in this region in the last 300 years, that one can happen at any time now.
So there would be almost no warning for this type of situation.
That's right, because it's so close to the coast that there's really no time to warn people. Yeah, it's very, very serious situation, I think.
And we've been seeing a lot of activity, and I mean a lot of activity in the southern Alaska area, the British Columbia area. I think there were about 400 earthquakes, aftershocks that occurred. I think it was about 10 days ago, maybe a little bit more. They had a pretty big earthquake. I think it was over a magnitude 6. And then just constantly for days, tremor after tremor. But the tremors weren't small. They were pretty sizable, and they were all concentrated in an area, and they were blaming it on some type of glacier movement.
Yes.
Considering everything that is going on with our planet, that, you know, a glacier melting would cause, you know, a magnitude 6 earthquake, and then 400 or 500 or 600 tremors like that. And this is happening all over the world. It happened the week before that, right off the coast of Chile. They had one big earthquake right off the shore. It was felt nearly 100 miles inland near the capital of Santiago. And then within the hours, it started out 40 aftershocks, then it went up to 60, and then it finally calmed down. But the situation occurred again. So I think we'll be getting into the transfer of pressure back and forth across the Pacific Ocean. And you know, this is a huge factor, because there are millions and millions of people that live in this area. And as the doctor said, there's nowhere to run to. The city of Seattle, Washington, and Vancouver, and these areas along the coastline, if this happens suddenly, and with the current situation that our planet is in, this would be probably the most devastating situation that this country has ever been involved in. And there would be a massive loss of life instantaneously. The liquefaction factor, it would definitely occur in this situation. They were talking in several other reports about a magnitude 9.2 and above. Even without the liquefaction factor, a 9.2 earthquake that would happen suddenly with the snapping up of that plate, that tectonic plate, would be just absolutely devastating. The tsunami would wash inland through the inlet there in Seattle. It would completely inundate the entire area in minutes. And there's no idea on how long the actual shaking would occur. So those are kind of some unknown factors, but you know, a magnitude 9 earthquake near a major city along a coastline, well, it is a recipe for a massive disaster.
Yeah, that's right. Yes, and I like what you mentioned about the earthquakes in Alaska, because the earthquakes in Alaska are in an adjacent region, right? And we often get transference from an adjacent region to another. For instance, the San Andreas Fault is adjacent to the Cascade subduction zone. So an earthquake in that area is very likely to cause an earthquake in the San Andreas Fault as well. So we could have the whole of the west of the United States being hit by a tsunami at the same time. And it has happened that for the last 3,000 years, that often when there's an earthquake in the Cascadia zone, then the San Andreas Fault also has an earthquake.
So it would actually trigger the San Andreas. Well, that would just be the tip of the iceberg. that would just
Yeah.
inundate the entire west coast of the United States.
Yeah, so in this diagram, I actually show you what my theory is about what really causes earthquakes. And that is the magma inside the earth. That is not just moving up and down. It's actually, I believe that it's carved channels inside the mantle and the crust. And how do we know they are channels? Well, some of these channels lead right up to the surface of the earth where we get a volcano. Magma rises up, goes up through that channel, and it comes right up to the surface. It becomes what we call lava, but it explodes. We get a volcanic eruption. So here I show lava flowing through channels inside the earth, and the blue arrows show the direction. And what causes magma to flow? Well, don't forget it's a liquid, and the earth is rotating. And if you have a rotating object with liquid in it, then the liquid is going to flow. The actual rotation will cause the liquid to flow around the whole earth. And the same thing happens with the ocean and air. Air is a fluid, and that's why we get currents, air currents and ocean currents. And this is all to do with the Earth's motion that actually causes these fluids to move. But what is happening to the Earth right now is it's wobbling. So when the Earth wobbles, then the flow of these fluids becomes disorganized or chaotic, or it flows faster and in different directions than before. And when that happens, of course, it's going to affect, well, we know it's affecting the jet stream, which is breaking up and becoming chaotic. We talked about that. But the same thing will happen to the magma inside the Earth. Backwards and forwards in these channels, more than usual. But what actually causes earthquakes is when the magma is forced upwards into chambers that are sealed from the surface. And that's what we see there. I've put in the diagram 2 sealed chambers. So yes, so when the magma is forced up into these chambers, it actually explodes into the chamber and causes a type of earthquake down there, which is then puts pressure on the fault lines that are close to those chambers. You see some fault lines there. Also, what can happen is if there's an earthquake at a fault line, it affects the flow of lava close to that fault line. The lava would then flow away from that region and perhaps go inside another sealed chamber, which is the next sealed chamber along that channel. And then that will affect the next fault line. So this is actually why we have, say we have earthquakes in Japan, which is on the other side of the Pacific plate. And then that will cause the magma to flow in the opposite direction, say towards the other side of the Pacific plate, and then where it's adjacent to the North American plate. And then the lava will be forced into a chamber up in that region, and that then causes that fault line close to North America to have an earthquake as well. So that's why adjacent regions are affected in this way. It's because of this lava flow and these chambers, these sealed chambers that we have inside the Earth, because not all of them lead to the surface. Those that lead to the surface, that's where we get a volcano.
Yeah, I've heard Dutch synths refer to this transfer of pressure, and that's, I guess, one of his techniques that he uses with very accurately forecasting these earthquakes. And I've talked with Terrell from Terrell, the Black Star Project, and Terrell has gone over a lot of this information also, and very, very, very similar views on what occurs underground And I personally, I never knew that was actually what occurs underground with these chambers of magma, and therefore the transfer of this pressure from one region to the other. And it doesn't happen instantaneously. It does take a couple of days, but that is one of the techniques that they use in forecasting these earthquakes, and it's pretty accurate. You still with us, Doctor?
Oh, yes. Sorry, I didn't hear you for a while. I'm glad you're still there.
Okay, you can go
Okay,
ahead.
so
and
I
pick
missed
up where
what you said.
Well, what I was saying is I was talking about how Dutch Sintz and Terrell from the Black Star
yes.
Project, they have talked about this transfer of pressure back and forth in these magma chambers, and I mean they're pretty spot on with the forecasting with this transfer of pressure, specifically across the Pacific Ocean. And you know, it's just a very bad situation that we're in right now, dealing with the west coast of the United States and this Cascadia subduction zone, because I mean, you know as well as I do, we were talking about it today with what we were looking at with the magnetopause and the solar wind and the pressure that is placed on the Earth. I mean, just thinking about it, ladies and gentlemen, if you have a ball that is fractured all over it and you add more pressure to the ball, well, the cracks are going to literally explode or fracture even more. And after looking at some of the models today with the solar wind and the magnetopause, there is absolutely no doubt that currently, right now, as we speak, we are under this severe pressure. And at any second, any minute, this could occur. What we are talking about right now. And the reason for this live stream today is to give you the basic dynamics of what could occur. And as I was mentioning before, we're starting to see earthquakes around the world where they normally don't have earthquakes. So, you know, just because you live in an area where you've never heard of an earthquake, you've never felt an earthquake, doesn't mean it can't happen. Because now, all of a sudden, this pressure is transferring all the way across the United States, through Oklahoma, through the South, and right up the western edge of the Appalachian Mountains into the east coast of the United States and into Canada. The same thing is going to apply for the rest of the world, for the Mediterranean, for Europe. We've already seen some small earthquakes in the English Channel, small earthquake in the UK, several earthquakes in France, Spain, Portugal. So the bottom line is, you know, we really, really need to keep our eye open and our ears open for everything going on around us right now, because there's nobody on the face of this earth that's going to tell you. There are very, very few people that are going to want to educate you on what could happen and probably what is about to happen. But go ahead, Doc. You can go ahead and continue.
I think you made a good point. So what I mentioned before is the fact that the Earth is wobbling will increase the motion of the magma, which will, of course, lead to an increasing number of earthquakes. And there's also the fact that that we have, I don't actually go into it in this article, but I can mention it now, and that is that if we are hit by CMEs and fast solar wind, these cause induced currents in the ionosphere. I mean, it causes not induced currents, but currents, electrical currents due to these charged particles in the ionosphere. And that then induces currents on the surface of the Earth and in the interior of the Earth. And that heats up the Earth, the interior, heats up the magma, and the magma then will flow upwards towards the surface as well. And we get the same problem. As it flows up and fills the channels, we get volcanic eruptions and explosive filling of the sealed chambers, which leads to earthquakes. So the two things, and these objects with their magnetic fields, the strong magnetic field, that's what's causing the Earth to wobble from one side to the other, and it's causing this chaotic motion of fluids inside the Earth. So it's all about the presence of these objects.
Now, I've noticed, I've noticed also that over the course of the last several months, there have been several areas throughout the world that dormant volcanoes have just all of a sudden come to life. I know that there is, I forget the name of the volcano that is right under the city of Naples, Italy.
Oh,
yeah, it is massive. A fuego something. I forget the name of it, but I know the scientists a few months ago, they were really startled and really scared about the situation that was occurring there.
Yes.
I forget the name of that earthquake or the name of that volcano. But it's literally under the entire region of Naples. But it's a very dangerous situation. Again, ladies and gentlemen, we're already seeing volcanoes that have been dormant for a long time. And now all of a sudden, they're all in full eruption mode. There's a difference between intermittent eruptions and full eruption. I think right now, the last time I looked earlier today, there were over 30 volcanoes on the face of this planet that are in full eruption mode. Now, believe it or not, that's kind of a good thing because the release of this internal pressure is good in a sense, but having a massive volcanic eruption, well, you know, that would be a totally different story. But God forbid, God forbid anything happen to the that volcano. It is massive in that Naples area. Chris, do you know the name of that? That volcano, and it's under Naples. I forget the name of it. Naturally, it has an Italian it has an Italian name to it.
Can you hear me?
Yeah, I can hear you.
Oh, Campiflegrei.
Oh, that's right. That's right. Campri.
Flegrei. Campiflegrei.
That's right. That's right. Yeah.
Okay.
Yeah, that's a brutal one. That's a brutal one.
But if you just do a search right now on Google, it's saying Campiflegrei, one of the world's most dangerous supervolcanoes, could, you know, etc. Campiflegrei volcano eruption, possibly closer than thought, 4 hours ago. Experts warn Campiflegrei is at a critical stage 8 hours ago.
Wow.
Wow.
So,
all of this is coming across the wire now, Chris.
Yeah, those are 6 hours. So the last three reports, all I did was Naples, Italy volcano. And then what came up was top stories, 6 hours old, 4 hours old, 8 hours old of that specific volcano.
Oh boy.
So, right? Then
Yeah.
how serious is that, Abu?
Yeah, and I've been to Naples, Italy before. The roads are very small, very narrow, you know, semi-mountainous. there is no way to evacuate in an emergency. There, it is a very, 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 very heavily populated area. There's no idea to even judge the amount of people there because of all of the tourism. So at any given point, you have millions of people there. And and then not too far from that major super volcano is another smaller volcano. So, you know, I don't know why people like want to build these beautiful cities, you know, near these damn volcanoes, but they do. And this is pretty much, I don't know. It's
actually no, that's a pretty serious warning right now. What's weird is you would even mention the volcano, and there is serious news on Google. Just the direction, you know, to Daily Mail, wherever, Reuters, phys.org. It's saying that it's a super volcano. It's at a critical stage. The volcano has been restless since 1950 with regular earthquakes. Excuse me. If it does erupt, experts believe it would affect 360,000 people at least, nearly up to 1 million. It hasn't erupted since 1538. And that's about all I found so far. But yeah, there's just a couple of really interesting articles today. And I just wanted to reiterate that that's not, you know, something we're just kind of throwing out there. It's actually, they're a little bit concerned. So go ahead.
Yeah,
folks.
one of my subscribers had mentioned it in the live chat. Dark Angel had mentioned it.
Oh,
and
good job.
yeah, it's if you look at that volcano from an aerial view, you would miss it because it doesn't have the cone shaped characteristics of a regular volcano. I mean, this thing is, I can't even describe it. If you want to take a look at it on Google Earth, I mean, you wouldn't even recognize it to be a volcano. And I believe that was from the last major blast that it had. And
yeah, he's a little guy.
yeah, it's just it's a very, very, very critical point on this planet. And yeah, and there's nowhere for people to go.
Yeah,
you're stuck there pretty much.
Yeah, he is kind of like a little baby volcano. It's kind of interesting. I've never seen anything like it.
It has to do. It has to do with the amount of lava in the chamber below the volcano, and supervolcanoes often don't have the cone because when they erupt, the whole ground level just falls into it because it's just such a huge crater.
Yeah, that's what it looks like now. It looks like a big, massive crater.
Interesting.
Yeah.
Yeah. The same thing will happen with Yellowstone. That's why there's no. Yeah.
I have nightmares. I have nightmares about Yellowstone because, you know, they're hiding information up there again with the seismic activity, and you know, Yellowstone. That's a whole nother ball game right there. I mean, that is almost over a third of the United States. That magma plume underground stretches all the way from the U.S.-Canadian border, I think, all the way down under New Mexico and Arizona. It's huge. It's massive. It's about a third, I think, a third of the United States. It's a very critical situation, and you know, I understand that everybody does realize the warning, but under the current situation that we're in, any one of these horrible situations can occur at a blink of an eye. No warning. Just happen. And with the amount of stress and pressure our planet is under right now, as we speak, as you're watching your computer monitor or your television or listening to this on your cell phone, This is occurring, happening right now. And there are reasons for it. And this is why we get criticized and tortured so badly, is because we know the reason why. And I think that this has to be the biggest cover-up in world history. And we're living it. We're living it right now. There's
that caldera is 35 to 55 miles. 34 to 45 miles in diameter, which is 55 by 72 kilometers. Excuse me, 35. Let me do this again. 34 miles by 45 miles, which is 55 by 72 kilometers. So yeah, he's a pretty big dude.
Oh my.
So that's the Yellowstone caldera, just on Wikipedia. Go ahead.
Mm-hmm.
Man.
Yeah, that's huge. Yeah, so I do mention that the best way to predict earthquakes is to actually observe how earthquakes transfer from one region to the next, and how Dutch sense is actually doing that. Is probably the only one on Earth that's doing it.
He does. You explained that perfectly.
Yeah.
And he gets harassed. He does get trolled by the USGS and other folks directly. And that's not yes.
It's terrible, man. What they do to Dutch is, you know, ladies and gentlemen, it's the same thing that they've done to the professor. You know, you're looking at two very highly skilled individuals that want to do nothing but help, that want to bring information to the world population. And I'll just be blunt. They get screwed. They get screwed. And, you know, we can't come to the point where we just stand for it anymore. We cannot. Because the bottom line is, the more they screw us, the more danger we're in. And we just can't have it anymore. It is just time to stand up and fight back. That's just the bottom line. There's nothing else to say.
Did we finish the article?
No.
Oh, okay. Sorry. We're on figure 13. Yeah, I sound really intelligent right now.
Oh, yeah, we're getting into the,
okay, so I was just kind of curious where so we're still, I mean, it's obvious that the theory, Doctor, is that there's objects close to the sun that's causing the sun to freak out, which is causing changes, i.e. earthquakes and volcanoes. That's the premise that we're discussing today. Is that right?
Yeah, that's right.
Okay, cool. I was just doing a recap real quick, and I wasn't trying to cut you off. This is a really well written document, so I'm glad we're covering it. We'll go ahead and continue. Thank you.
Okay, thanks, Chris, and thank you, Scott. You know, you two have always are trying to protect me and help me, and I'm very thankful.
No need to thank either of us. You know, it's just the way that I am. Chris is the same way, and you know, we're all a team in this, and I mean me and you and Chris and all of the viewers and everybody around the world that wants the information, that wants to learn what is happening. And you know, I mean, there are points in time that, you know, all of this makes me very sad. You know, I mean, I've mentioned this before. I never thought in a million years that the latter part of my life would turn into this. But it is what it is, and I'm not giving up. I know Chris is not giving up, and I know you're not giving up. And, you know, there's no need to thank us. You know, we we are thanking you because, as I mentioned earlier in one of my videos, that you've brought so much light and so much knowledge to me and so much insight, things that I puzzled myself with for a long time. And now, through all of your papers, all of your reports, all of your research, it's helping me bring more of this information to people around the world, you know, and getting censored and people trying to shut you up and close you down. Well, that just pushes me even more. And it's not going to happen to us. It's not going to happen.
Yeah.
But we'll go on.
Thank you. Yes. Thanks, Scott. All right. So I think this is my last diagram. Here I show, because people usually want to know what is the gravitational effect of objects near the Earth. And I don't usually focus on the gravitational effect because it's quite a weak force. And it pulls the whole area, the fault line, in basically upwards towards the object. So it may not actually affect the forces much. It may have a small effect. So a planetary alignment will maybe increase the forces and the stresses on a fault line a little bit. It will also have an effect on the magma. So the magma will be maybe pushed up. It may end up going into a sealed chamber, which then causes vibrations and the fault lines to be affected. But as you know, I don't think the gravitational force is a strong factor in anything that happens on Earth. I think it's got more to do with the very strong magnetic field that these objects have, because don't forget what a brown dwarf is. It's actually a white dwarf that through time has cooled down. And I know that people say that there isn't enough time in the age of the universe for a white dwarf to cool down to a brown dwarf. But I actually believe that star formation and the way stars work is a little different from the accepted theory. So I think they may cool down a lot faster than the accepted theory says. Also, I don't actually believe in the Big Bang theory. So I don't think there is, I don't think the universe is 18 billion years old or whatever age is assigned. So that doesn't come into it. I don't actually believe in the Big Bang model. So that's not the factor. But these objects are basically objects that were like our sun when they were still producing light and still had fuel. And they have been condensed down to a small size, sometimes the size of the Earth, if it's an iron core brown dwarf star. And these objects are therefore extremely powerful. They rotate very fast. They have extremely strong magnetic fields. And I think it's mainly their extremely strong magnetic field, which could be 1,000 times larger than the sun's magnetic field, that causes all the trouble that we see in the solar system. For instance, we see this huge increase in the magnetic in the wobble due to the Earth's magnetic field shifting, because these objects are going to affect the Earth's magnetic field, and they're going to affect the sun because of that huge magnetic field. They connect magnetically to the sun. The magnetic field lines in the sun open up. The solar particles from inside the sun flow right out towards these objects. And that's one of the reasons why the sun is getting so drained. It's because it's mainly about these objects' magnetic field. And people worry also about these objects having come into the solar system. And don't forget, we have objects coming into the solar system. And I think we were talking earlier about how Jupiter has captured so many planets. and it now has so many planets around it. I mean, Jupiter and the rest of the planets in that little particular small, almost like a planetary system with all these planets around you, they were not destroyed because Jupiter captured more planets. So it's the same thing with the sun. The sun can capture planets, and now it seems to be capturing stars. So the stars are coming right into it and seem to be attracted to our sun. And I think I've talked about that a lot. And so these objects could go past the Earth and towards the sun and not destroy the Earth. It will have an effect. And the effect that we see are these earthquakes, these volcanic eruptions, the chaotic weather, because the Earth is wobbling as a result of the change in its magnetic field. So I hope that helps, Scott.
Oh, absolutely. That was a presentation that reminded me of something that came from like the History Channel or the Discovery Channel.
Okay, that's good.
Yeah, absolutely, no doubt. I was just getting a report coming in right as you were finishing up. Mike from around the world was just giving a report on what's actually happening right now, and I am right in the process of pulling up the ISWA solar wind so we can actually take a look and see what's happening. I know me and you reviewed this information earlier, but we're going to go ahead and we're going to show everybody exactly what is happening right now. We can give a little talk about what's actually occurring right now.
Good.
Here's the real-time solar wind. And
wow, look at
this
that.
is up to date. You can see the solar wind has increased. It was down about 360 kilometers per second. It has risen now to 537, 540 kilometers per second. However, there was a very large spike way over 750 kilometers per second earlier this morning. And you can see these arrows that we're looking at right here. This is the direction of this solar wind or this energy, but it seems it's coming in pulses, and it's actually gotten worse. You can see how red the bow shock in front of the Earth. Pretty intense.
That's high density of particles hitting the bow shock. It's very high. It's almost at maximum.
I think it is at maximum, to tell you the truth. It is. In
places it is.
Yeah, it's fluctuating back and forth, and
then the direction of the solar wind inside the magnetosphere is showing signs of reversal.
Yeah.
And that means there's an opposing solar wind coming from outside of Earth's orbit. Or maybe a little bit to the side, not exactly right behind the Earth, from the direction of the arrows. It's very interesting. So it looks like there's an object there.
Yeah, I'm going to bring up the magnetopause also. Just take a look at it, because it's been a few hours since we examined it, and I knew this was going to be coming in around the 14th or 15th, and we're not going to be out of the woods in like 24 hours, because we have several large coronal holes that are Earth facing now. There is another one coming around the left side of the sun that will be Earth facing in several days. But as you can see, very, very erratic.
Yes.
Magnetopause, the magnetic field lines, the black lines, they're supposed to be in a steady flow right along the sides. And you can see how erratic. You can see the very, very high density of the bow shock here in the front, which is like a burnt orange.
Definitely.
Yeah. It's in it's in some serious shape right now.
Yeah, it looks like, you know, they talk about these stealth CMEs, and I knew the moment they mentioned them that it was some kind of way of hiding what's going on. We've never heard of them before. So I think what these stealth CMEs are the particle flux transfer between the sun and one of these brown dwarf stars. Because as you can see the high density of particles hitting the bow shock, that would mean that there's lots of particles coming off the sun, and there seems to be an object behind the Earth, because we see these reversals going into the magnetosphere as waves. So that would mean there's an object behind the Earth. So what happens is the particles are being pulled right off the sun and are coming towards this object. And that's why there's a high density there, hitting the bow shock. That's what I think. Also, the magnetic field, you see, the magnetic field lines are very close to each other. That means a very strong magnetic field. And we were watching it earlier. We actually see areas of totally entangled field lines to the point that they look like black regions. That shows there's an intense magnetic field behind the Earth. So
I could bring that up real quick so we could see that. We'll let that load, and hopefully they didn't take it down, but I made sure this time that wow. I made sure I screen captured it, so there is no way that they could say it did not happen.
Yeah.
We recorded it. You can see this is bad. This in front of the bow shock here. That's very intense. That's about as intense as you can.
It is. Yeah, it's at maximum.
Okay, I'll have to go back a little bit more in time.
Yeah.
Let's see if we could pick it up and we could show everybody, because that was pretty intense what we saw this morning.
Yeah. Indeed, it was. And there's definitely something happening.
Oh my God!
Yeah.
Look at that.
Oh my goodness. That is, my goodness, that red doesn't even show on the scale, Scott.
Yeah.
It's redder than on the scale. Oh my goodness. Oh, look, and the particles are being pushed past the magnetosphere. Did you see that?
Yeah, I did see that.
Oh, and they were still red as they were being pushed past. So high density, very high density. Amazing. You see, these are the particles that are getting pulled off the sun by these objects in the solar system. This one is not in the inner solar system that's pulling. It's obviously behind the Earth. So it's in the solar system, but not in the inner solar system. But there are plenty. Oh, look at that.
Yeah, it's replaying, and this is going from 8 a.m. on the 14th.
Wow. Oh my goodness.
I've never seen it that red. I've never seen it.
No, I haven't either. I haven't either. This is. And you can see the entangled field line showing the intensity of the magnetic field behind the Earth. Wow.
Yeah, this is very intense. I mean, I'm a little bit speechless. I mean, that's about as intense as I've ever seen it.
Yes.
It's not a joke.
No, it's not. This is very, I mean, it's gone to maximum. So you can imagine it could go on increasing, and it's right off the scale. So we wouldn't even notice if it gets any worse.
Yeah. And people are all over the Earth, you know, just going about their everyday business, not realizing what is actually happening. And at any minute, anywhere on this planet, all hell can break loose instantly.
Yeah, that's right. Because don't forget, some of these particles always get in. They will go to the poles. They will get into the ionosphere. They will induce currents on the surface of the Earth. And then that's when we have power grid failures. Will cause induced currents and increased currents in the magma, in the outer core of the Earth. It will heat up the magma, and then we are going to get more earthquakes and more volcanoes erupting. This
Lord
is,
have mercy. Look at
oh
this.
My goodness.
This is
Oh my goodness.
This has all just been updated. This is current right now as we speak.
But that's above maximum. This is redder than maximum.
Yes, it is.
And it's inside. It's inside the geosynchronous. Is it okay? Is it okay, Chris? Oh my, it's inside the geosynchronous orbit.
Yeah. Yeah, this is bad. This is bad. This is bad.
I never thought I would see something like this, Scott. This is unbelievable.
I've seen this a couple of times, since I started paying attention to the radioactivity bombarding the Earth over the past couple of months, going back to around December 2016. I noted several occurrences of the entire field being completely red, but this time it is a different color. It's not the dark, deep red. It's not even, like you said, it's not even on the scale.
No, this is above the scale. It's almost a pinky red.
Yeah, I've never seen it that color before ever. I've never, as many years as I've been looking at this, I've never seen it that weird color.
Okay, so it's for the 15th. Is it for the whole day?
Oh, this is going to be impacting for quite a while.
But I'm sorry, the footage that we're looking at now, is it just like a clip for 24 hours or?
Yeah, this will, let me see. This will go back in like, let's see when it stops.
He's like 3 or 4 hours or something on
this is UTC time, so this is going back to about 4 p.m. UTC time.
Oh, today's the 15th. Duh.
Yeah, this is current. This is happening right now.
Yeah, it's
Chris. But I want to ask a question. How can we cross verify? Like, I was looking at some space weather stuff. Like the Space Weather Prediction Center, just to kind of cross verify what we're looking at now. It didn't really give me. It's swpc.noaa.gov. Anyway, it wasn't giving me anything really worth sharing. I figured I would at least ask, what else could you use? What other site would you use? Is this something?
Well, this is basically the only real-time model that is up there with a satellite, and that thing is getting overwhelmed. I just increased the amount of frames from 10 to 100, which actually takes it back in time, shows you more footage. It actually shows you this coming in.
Yeah. Good idea.
But do you see that it's coming in from the wrong direction?
It's coming in from behind the Earth.
Exactly.
Well, he goes counterclockwise. Didn't you see that?
Yeah. This is coming from behind the Earth.
I understand.
It came from behind the Earth, so that means it's not coming from the sun.
Okay. The motion is counterclockwise. The red is what I was mentioning.
Yes. Okay.
That's all I was saying.
Yeah.
Yeah, that's fine. But you see that the particles are, look where they're coming from. They're coming from behind the Earth. The sun is on the other side.
Holy hell.
These are not solar particles. These are coming from the other object behind the Earth. Particle flux transfer. Remember what I've been saying. The sun sends particles towards this object then sends particles towards the sun. It's a transfer of particles, and what we are seeing is the Earth getting hit from the other side. So the Earth ends up having two bow shocks, one on either side, because now the magnetic field has to oppose the particles on two sides. That's why it looks like that.
I mean, we're looking at this in real time, ladies and gentlemen. We're looking at this as it's happening right now. Now, there is one small factor that does add to this, is when the moon is close to a full moon phase, you know, some of this radiation does bounce off the moon and come back in, but nothing like this. Nothing.
No, not this amount. This is above maximum.
Yeah, this is a bombardment. I'm not even going outside today. I could tell you that much.
Well, I think our geosynchronous satellites are in trouble.
Yeah, because that's the little dotted line, ladies and gentlemen, is the satellite belt. And wow, those poor little machines. That's a lot of radiation right there. That's a lot. I'm sure, I know BP Earthwatch is, he's been tracking all of the radiation levels around the world with a new site that he has up where people are able to report their radiation readings from around the world. And he was just doing a report on it the other day and talking about it. And you can see the increased radiation levels around the world. I mean, almost everywhere. Now, they do fluctuate somewhat, but they are on the rise. And, you know, while we're talking about that subject, the UV rays, once again, you know, Mike from around the world, he's been updating constantly the UV rays, and they are off the chart. Very dangerous levels. And even for this time of year, and he was charting that back in the winter time in the Northern Hemisphere, the UV index was sky high. Yeah. So, I mean, we obviously have a lot of issues, a lot of things happening around the world. There's absolutely no doubt. Not all of this is coming directly from the sun, but there is definitely major influences on our sun, and we know what they are. We know what they are. And eventually, we're going to hit the pinnacle of all of this, and it's going to be the point of no return. That's just the bottom line. And when I say it's time to awaken, everyone, it is time to wake up and realize, yes, you may have your doubts about mysterious planets, brown dwarf stars, you know, theoretical planets, Nibiru, ancient writings. You may have doubts about all of it. That's fine. You have that right. But when you are seeing things happening in real time, right in front of your face, there's no denying it. There's no denying it at all. Yeah. Pretty shocked. I'm pretty shocked at what I'm seeing right now.
I am too. I cannot help but I am just shocked at seeing these particles coming from the wrong direction.
Yeah, I'm actually, I mean, I actually had a sickening feeling just go over me right now in my stomach, because I have a feeling that the rest of the, like I mentioned, the rest of the month of May, we're not out of the woods, ladies and gentlemen. We have more of this coming. This right here was just a small beginning that started on Mother's Day, May 14th, 2017.
Sure.
Just a horrible way to remember a beautiful day. And here we are, staring at it, Right in our faces. I'm going to take a quick look at the SDO, and I want to see what's happening. Okay. Everybody.
Yeah, I was watching the video that Chris made of SDO, and I was noticing the coronal holes are growing, but they're not reaching their largest size when they are exactly facing the Earth anymore, but a little bit after passing the position where they would be facing the Earth. So that shows you that the object that was in line with the Earth and the Sun has moved off a little bit further to the right. And now, because obviously it's orbiting around the Sun, so we're getting the largest coronal holes now opening up just a little bit after the coronal hole is facing the Earth, which is interesting. I find that quite interesting. You see that the coronal hole.
Yeah, you're correct. They were opening up Earth facing. They were getting much larger Earth facing, and then as they faded to the right, they were starting to close.
Yeah.
But we do have this one on the left side that is coming. And you can literally see this opening up right in front of your eyes.
Yes.
And it's kind of rare to see this on the SDO.
Yeah.
But you're starting to see it with your own eyes.
Yes, there it is, opening up. Yes, exactly.
And here we go with some major sunspots that are going to be coming back around. And once again, you can see there is no corona. No corona at the top of the sun or the bottom. Nothing. That's right. Zero. It's gone.
Yeah, and the sun is much darker than it should be. Overall, the corona is much darker and smaller. It's just large there on the left. And that's usually where there are objects that are actually pulling plasma right out of the sun. And they sometimes that can cause the corona to look like that, larger than what is normal for the sun nowadays.
Yeah, I'm going to pull up the X-ray from the GOES satellite real quick. And we'll get a real quick bead on what's happening with this.
Yes.
Let this load. It's not even moving. Wow, look at this.
Well, we can see the large coronal holes. There's such a huge region of the sun that is just not emitting X-rays anymore.
Whew,
and it's just huge. And that shows how weak the sun has become, because X-rays are the highest energy radiation it emits. Well, if we don't think of the cosmic particles, of course, and it's strongly affected. You can see it, that emission.
Wow.
That's huge.
Yeah. Yeah, we definitely, excuse me, we definitely have some issues.
Yes.
That we should all be a little worried about. And I'm gonna share a few of these pictures real quick before we end our live stream. I wanted to show everybody once again what I captured yesterday at a different position. Yeah, this is going to blow everybody's mind once again.
Yeah.
I'll let this photograph load.
Yeah, it blew my mind when you showed it to me this morning. I just couldn't believe it. And the most interesting thing about it is that it's actually so beautiful. It's a beautiful object.
Oops. Where did I put the beer? It is. Sorry, I pulled up the wrong picture.
Okay.
I'm getting there.
Okay. It will be worth the wait, I think.
Okay, and I'll pull up the other one here real quick. Nope. Boy, I'm just a big disorganized mess here right now. Okay. Okay. I got them all. Okay, that's it there. And we'll just share the screen once again. And ladies and gentlemen, I took a few of these pictures yesterday as the sun burned through my filter. And this is what we came up with again yesterday.
Wow. It's amazing. A blue-brown dwarf with yellow stripes.
Yeah.
It's amazing.
Yeah, you can see the housing of the telescope right here. And this is just the top part of the sun. You can see how, yeah, that's just,
Wow.
it's a little blurry, but
Yeah.
I'm hoping I didn't damage my camera.
Yeah.
Because I took these photographs without a filter because the filter was it was burned, a hole burned right through it.
Yeah.
And the sun just looked completely white. It basically had no color. It was just completely 100% white. It had just no color whatsoever. And you know what? I think I had just.
Well, it's not normal for the sun to be white. The sun is supposed to look yellow inside the Earth's atmosphere.
And it was just completely white. Just a big white ball.
That's just not normal. So it could be that they had a simulator in front of the sun, but maybe the simulator is not working anymore to cover up all the objects. Maybe that's what's happening.
Either that or they were trying to blind me. You know, one of the two. You know, maybe they turned that thing up and they said, hey, let's get Scott out of the way. Let's blind him.
Yeah.
He already, you know, blinded himself once.
Yeah.
You know, let's blind him again. And here was the photograph that we were looking at.
Yes.
And you can see right over here.
Yes.
The edge of the sun. Nothing was done to these photographs. You know, no imaging, no contrast, no nothing. You're looking at a raw picture.
Yeah. Wow. And what I can think is when I look at it is how beautiful it is. It's blue.
Yeah.
A beautiful blue color with some yellow stripes.
Yeah, aqua blue's all,
It's a
it's always been one of my
beautiful
favorite
object.
colors, but
Mm,
looking
yeah.
at looking at this object, just I'll be quite honest with you, it scares the crap out of me. Something that we didn't see in the other images that I took on May 10th, we didn't see
Yeah.
any of this yellow discoloration. Now we're seeing
Yeah.
different views of it because this view is coming from the top part of the sun. The photographs that I took on May 10th, this object was at about the, I'd say the 7 o'clock position. This here
Mhm.
is pretty close to about the 9 o'clock position. So we're looking at 4 days have passed, and
Yeah.
at least we can show and prove that the object is moving, it is orbiting, it is there. And something that I noticed, this discoloration at its I guess it would be its south pole.
South Pole.
Yeah.
Yeah. Yeah. Wow. That's right.
Yeah.
That's
So
amazing.
I mean, I don't know. When I look at these objects, I just now I know beyond a shadow of a doubt that
Yeah.
they're there. They are affecting the sun. Everything that we talk about, we've researched, we've investigated. This is all happening. This is all affecting our planet. And I mean, we are living in the sign of the times. This is it.
Yes.
So I don't know. I'm getting speechless and I'm starting to stutter looking at this damn thing.
It's almost unbelievable, but there's the evidence in front of us. It's a photograph of an object right next to the sun. Look how close it is to the sun.
Yeah,
it looks like almost touching the sun.
Yeah, it's
how close it is.
Very, very close. I was trying to figure out the perception of actually where it is.
Well, it has to be behind the sun, slightly behind.
Yeah, that's what
otherwise we wouldn't be able to see it, because these objects don't emit light, they reflect light. So it has to be reflecting the sun's light, and we seeing the whole object, we're not seeing part of it. So it has to be slightly behind the sun. So that tells us that it's absolutely huge. Like I said the other day, it's about 1/3 the size of the sun, which would make it 3.3 times the size of Jupiter.
Yeah,
I've just
changed the filter so we can, we can just take another perspective of it. But yeah.
It's absolutely huge object. And it's a brown dwarf. I mean, what else can it be? It's a brown dwarf. And I've actually been thinking that maybe these brown dwarf stars and these brown dwarfs are more closely related than I thought before. It's possible that brown dwarf stars go through a stage where they can be rejuvenated and start emitting light again. They are still white dwarfs that have just become dark, and that they go through a stage that eventually they are not able to be rejuvenated anymore. And then they become these brown dwarfs where they actually have cloud formations. They're still gaseous. Stars are gaseous objects. Gas giant planets or gaseous as well. It could be there's a transition between star, white dwarf, brown dwarf star, and eventually a brown dwarf that is not able to be rejuvenated anymore into a star. And that makes me think that perhaps Jupiter is one of these. Perhaps we have more than one star in the solar system already, and that Jupiter was one of those stars.
Yeah, and before all of the comments and the questions, ladies and gentlemen, no, this is not the planet Jupiter.
Definitely.
Even though it looks a little bit like Jupiter, this is not the planet Jupiter. It's in the wrong place at the wrong time, and it's just
exactly.
It's just not Jupiter.
Yeah, it's a lot larger than Jupiter. It's at least 3 times larger than Jupiter.
Yeah,
and it's not the same color as Jupiter. And there's no way Jupiter could be this close to the sun. Well, first of all, if it was at that position, Jupiter would look a lot smaller than that object. But Jupiter, there's no way it can get to the inner solar system. It's in a stable orbit out there in the outer solar system. And it cannot get to the inner solar system as we see this object is. This object came in with the brown dwarf stars. This object either orbits one of the brown dwarf stars, or it's just part of a whole group of brown dwarf stars and brown dwarfs that came into the solar system and came right up to the sun and are now orbiting the sun.
Yeah, that you know, I'm serious. Whenever I'm looking at these photographs now like that, I get speechless because now I know deep in my heart that there's something else out there.
Yeah.
And well, it's there.
I think there's more to discover, but I think we've made a leap in our understanding and the evidence that we've managed to get by you getting these photographs, Scott. This is just amazing. It's evidence like I never thought I would see, because I thought they would continue to hide these objects from us. I still think it's a miracle that you are getting these photographs.
Yeah, I'm actually, you know, I'll be quite honest. I was actually scared to show the original photographs from May 10th. And then when I was able to capture it again at a different position yesterday, I thought to myself, oh God, you know, what do I do? But I mean, I have to show it to everyone. That's the main goal, is to let everyone see with their own eyes what's there, what the threat is. And it's real. It's not fake. It's not imaginary. And no, you're not only going to see it on YouTube, because eventually we are going to do everything that we possibly can to take the information to other platforms that want to interview us, that want to see the information. And we're going to do that. We are going to do that. There is absolutely no doubt about it. And in due time, and that due time is going to come around very, very quickly. And I'd like to take this opportunity to thank everyone. I want to thank everyone today who stepped up and is helping support the doctor, helping support this channel, helping to support me in the research that we're doing, and simply to find the truth and to find the answers. We're all in this together. That much is true. And we're going to continue, once again, each and every day. Absolutely no doubt about that. But Doctor, in closing, did you have anything that you wanted to say?
Well, I'd like to second what you said. I'd like to thank the people who support us, who are interested in learning the truth. We are here to tell the people who want to listen about the truth. And I believe that our Creator would like people to know the truth. And that it's just that time in the history of the earth and perhaps the universe when these things are supposed to happen. And it's a warning, I believe. It's like a clock, an alarm clock, telling people what time it is. and what they're supposed to do with their lives, and that is, get to know the Creator.
I wanted to mention
that is my message.
I wanted to mention to you real quick before we close out that I noticed a lot of people in the live chat that well, they were all saying they love you. They love you. They love you for the work that you're doing, and they appreciate everything. And that's coming from their heart. That's a big deal. I mean, for me, that's a big deal. I know it is for you too. And it's a fact of being appreciated and respected. And we all know the current situation that that has gone down at the university and with your life, and we're going to try to help and make it right. And we're going to just keep on moving forward. That's what it's all about. That's one thing that my mother and my grandmother always taught me is pick yourself back up, brush yourself off when someone knocks you down, and keep on moving forward. Don't look behind. Don't look back.
Thank you, Scott.
Yeah, that's what we're going to do. Well, listen, ladies and gentlemen, I'd like to thank all of you once again for joining in with us here today. Absolutely incredible information on the dynamics of earthquakes and possibly what we are going to expect in the very near future. Everybody keep your eyes and your ears open and stay tuned to Planet X News. And this is Scott and our physicist and professor. We would both like to thank you. Chris Potter had to step out. He also thanks you. And stay tuned. We will definitely be back with more information. And keep an eye in the sky. Take those photographs. Take those videos. Send them in to Nibiru Planet X 2016 at gmail.com. And for everyone who helped contribute and all of your donations, thank you very much. Love and peace. Take care.